Lightning, hotter than the sun. Tens of miles long, yet only an inch thick. The most powerful electric force on Earth. Created by ice, yet it burns. It kills. It injures.
I went through a year and a half of hell. Fire!
We can capture it, imitate it, but we can never control it.
Just got it. Oh, right down the side of that rain shaft.
Lightning, the violent power of our raging planet. The beauty of the clouds, majestic, tranquil, deceptive. For inside this storm cloud, vast forces are at work. Simple ingredients, moisture, heat, ice, combine to create one of the most powerful phenomena on Earth. Lightning. There are 10 million lightning bolts around the world each day, more than 100 every second. Each bolt is less than an inch thick and reaches miles across the sky. A stream of raw power, hotter than the surface of the sun. At any one moment, there are at least 2,000 thunderstorms raging across our planet. Lightning is all around us, a natural force of almost unbelievable power. Yet lightning is still a mystery to us, despite 200 years of research. We still have no answers to the most fundamental questions. What causes lightning? Where will it strike? And when?
I've been told that a single bolt of lightning is up to 20 million volts and about 50,000 degrees Fahrenheit. That's a lot of power. That's an awful lot of power, and I survived it.
Lightning kills over 100 people in America every year and injures 500 more. Around the world, the death toll runs into thousands. And its victims are not always beneath a thunderstorm. Lightning can strike literally out of the blue. This was the experience of Michelle Dougherty. She was struck while jet skiing on a clear summer day.
It was beautiful. It was hot and it was sunny, and we were rented 2 jet skis for an hour, and it was almost at the end of the hour that the accident occurred. We were out playing around on the jet skis and then heard after several moments a very faint distant rumble, and we were heading back into the docks, and someplace right in this area is when I was struck by lightning. It was never overhead, it was back beyond the trees, and I believe I've been told it's what they call arc lightning, where it travels ahead of the thundercloud about 10 miles or so and travels horizontally and then makes its contact, and I and the jet ski were its targets. Apparently it forked and entered my left shoulder, and a piece of it went through the jet ski.
Lightning singles out its victims with random, almost casual savagery. Small wonder so many cultures have seen it as a tool of the gods. For the ancient Greeks, lightning strikes were Zeus's thunderbolts, sent down as punishment. In New Mexico, the Pueblo Indians believed in the thunderbird, a mythical eagle whose eyes flashed lightning and whose wing beats were thunder. In northern Australia, the Aboriginal people have lived with lightning for thousands of years. From November to January each year, this land experiences some of the most powerful and dazzling thunderstorms in the world. For the Aborigines, this was the work of the Lightning Brothers. They painted them on rocks throughout the region. These were warriors, tribal brothers who fought over a woman. As their stone axes clashed, the sparks became lightning. The noise of the fight was thunder. In one story, the triumphant brother had children, rows of baby lightning flashes, waiting to be released. Yet even in this scientific era, lightning continues to fascinate us. And even simple questions have proved hard to answer. How do thunderclouds become electrified? What causes lightning? Thunderstorms are water and heat. When pockets of moist air are heated by the sun, they rise. As they gain height, the air around them becomes cooler, and the atmospheric pressure lower. The moisture cools and condenses to form clouds. This process lies at the heart of all cloud formation. But to create lightning, it must go further. When conditions are right, with enough water and heat to drive the system on, the first small clouds grow and merge into larger ones, rising all the time. Some of the water drops become too large and heavy for the updraft of air to support them, and they fall as rain. But strong convection currents lift the smaller droplets higher and higher, and in the cold upper region of the cloud, they freeze into tiny crystals of ice. At the top of the cloud, as much as 12 miles high, they spread horizontally, forming the flat anvil shape of a typical thundercloud. More water freezes onto the ice particles, and they grow into hailstones, which drop back through the cloud. They fall through the stream of smaller rising particles, causing millions of tiny collisions. Each collision knocks electrons off the rising ice crystals, giving them a positive electrical charge, while the falling hailstones become negatively charged. Eventually, the entire cloud becomes electrified, like a giant battery, positive at the top and negative in the lower regions. Something has to give. A huge electrical current rips through the air to neutralize the two charges. A bolt of lightning has been created. Lightning has lit up the skies since the world began. Scientists now believe that lightning may be the spark that created all life on Earth. 4 billion years ago, lightning bolts may have ignited chemical reactions in the primitive oceans to produce the first amino acids, the building blocks of life itself. And lightning still sustains all life today. In northern Australia, lightning has regularly ignited huge bushfires for millions of years. They clear the ground to allow new growth, a process of natural regeneration. The Aborigines saw how the land improved after it had burned. But lightning is unpredictable and random, and many areas were missed. So they deliberately burned large sections of bush every year, in a crude but effective form of land management. The bush regenerated, and the land filled with new life. The Lightning Brothers taught the Aboriginal people a lesson in survival. But as well as giving life, lightning can destroy it. Lightning kills 1 in every 6 people it strikes. Survivors are often left with severe injuries. Most doctors rarely encounter lightning victims and do not recognize the signs. One of the few specialists in lightning injuries is Dr. Mary Ann Cooper.
Hi. I'm Dr. Cooper. What happened to you?
I was at home on the telephone. I heard a big crack, and next thing you know, I was across the room. And I'm complaining of some pain in my shoulder.
Just the one shoulder?
Yeah, just the shoulder, and my ear kind of hurts a little bit. I just don't feel quite right.
Lightning, while you think about it as being tremendous energy, garden variety lightning is probably around 10 to 30 million volts and 10 to 30 to 50,000 amps. The vast majority of that really doesn't go through the person.
Did you get thrown out of the chair?
Yeah, just kind of out of the chair and onto the floor.
To the best of our knowledge, what happens when lightning strikes a person is it comes down through the air, sees the person as a different kind of resistor, different kind of object, goes through that person for a split second, and then flashes over the outside, almost explodes over the outside. So the vast majority of the energy really probably goes around the outside of the person rather than through them.
No belly pain.
And other than the numbness and tingling, you don't really feel much other than in the legs?
I just don't feel like 100% right, but yeah, it's just kind of tingling. They don't really hurt or burn.
Okay.
You ever had any of these problems before?
Never.
Okay. Can you squeeze my fingers? The only thing that we've found that kills people is if they have a cardiac arrest. That happens at the time of the injury. It's extremely unusual to have any other cause of death that happens after the initial incident. Can you burns?
Not that I can feel.
Yet despite the danger, people are still fascinated by lightning's beauty and power. At this amateur laboratory in Richmond, Virginia, a group of enthusiasts devote their spare time to recreating the power of lightning.
This Tesla coil, as you all know, this is Tesla coil number 11.
They build Tesla coils, strange electrical devices which generate huge continuous electrical charges.
We'll be ready to fire this system.
This Tesla coil creates 2 million volt sparks that leap 10 feet through the air. The result of their efforts is an impressive reminder of the raw power of electricity. The effect on those watching can be hypnotic. But our efforts to copy nature are really weak. No man-made machine can generate even a fraction of the energy discharged in a single lightning bolt. 90% of all lightning never touches the ground. It occurs inside the thundercloud, or jumps from cloud to cloud. A single bolt can illuminate an entire cloud from the inside. We call this sheet lightning. When a lightning bolt flashes from cloud to cloud, it forms ribbons, streamers, and spider lightning. These complex flashes are frequently many miles long, sometimes 100 miles or more. But the most dangerous lightning bolts go from cloud to ground. They rip through the air at a third the speed of light, carrying tens, even hundreds of thousands of amps at several million volts. Each bolt instantly heats the surrounding air to an incredible 50,000 degrees Fahrenheit, 5 times the temperature of the sun's surface. This explosive heat produces a massive, deafening shockwave. Thunder. One of lightning's greatest mysteries is why it takes a particular path through the air. Only now is science beginning to understand this. It begins in the negatively charged region in the base of the cloud. Here, thin, barely luminous electric feelers, called stepped leaders, zigzag through the cloud. In a millionth of a second, each feeler leaps about 50 yards, pauses, then leaps again, branching and forking through the cloud. Occasionally, a leader leaves the cloud and jumps towards Earth. About 100 yards above the ground, its intense negative charge begins to affect the land immediately below. Positive electrical charge collects in pointed objects, blades of grass, pine needles, tree branches, and metal poles. They emit upward streamers towards the descending stepped leader. If they make contact, the cloud is suddenly wired to the ground. A massive electrical discharge rips down the channel. The portion closest to the ground discharges first. So as the current pours down the channel from higher and higher regions, the visible bolt of lightning shoots upward at close to the speed of light. But that's not usually the end of a lightning bolt. If the cloud still has excess negative charge, a new leader may fly down the same path, creating another stroke. More leaders may follow, usually about 3 or 4, but there can be as many as 30 or 40. To the human eye, a lightning bolt appears to flicker. This video footage contains a rare example of an upward streamer caught on camera. At normal speed, this appears to be just another lightning bolt striking close by. But watching the footage frame by frame, just before the main lightning bolt, a snake-like streamer is clearly visible, shooting upwards from the ground. The lightning actually hit some distance away, because the streamer did not make contact. If it had, the cameraman would have been in extreme danger. Yet there have always been people prepared to tempt fate by putting themselves in the path of a lightning bolt. In 1752, Benjamin Franklin launched a kite into the heart of a thunderstorm and watched sparks jumping from the wet string to a key tied to his hand. It was the beginning of lightning science. Many of Franklin's inventions are still with us today.
Okay, we're going to talk about Franklin's bells. And this is an electrostatic device which utilizes what we call atmospheric electricity. Franklin designed this specifically to let him know when storms would be approaching. He would connect a ground to one bell, and he would connect a lightning rod or large antenna to another bell.
When a thundercloud approached, the air became electrified, and one bell became charged. The pendulum transferred the charge to Earth through the other bell. When the bells began to ring, Franklin knew a storm was approaching. But if he had fully understood the power of lightning, Franklin might never have flown his kite. Several researchers who tried to duplicate Franklin's kite experiment were killed. The destructive energy of a lightning bolt is almost inconceivable. If it hits a tree, the lightning seeks out the shortest path to the ground. If there is a damp crack in the trunk or a branch, it will follow that, blowing the tree apart. It may run down inside the bark, vaporizing the sap, which blows the bark off like an exploding grenade. Sometimes it will leap sideways out of the tree and strike anything standing nearby. A similar sideways leap almost killed Tony Scott, a telephone engineer in Miami. He knew the risks of working outside during thunderstorms and thought he took the right precautions.
I was here to add a second telephone line to the customer's house. I had just gotten off the telephone pole and hung the new service line to the house. It was hanging from the eave of the roof there while I was changing out the box. Next thing I know, I saw a flash. That's all I remember until I came to on the other side of the yard. The wire wasn't grounded or anything, and they tell me that what happened is lightning hit up on the pole there. Fortunately, went both ways in the cable, but also came down the service line, which wasn't grounded, and I was the closest ground. When I came to, I couldn't move. I was paralyzed, and I felt like I had a mouthful of silver, and I couldn't even spit it out because I couldn't turn my head or anything.
Often the victim will wake up after a strike still in the accident area and feel that they can't move because their lower extremities are paralyzed. Their legs, sometimes even an arm or both arms, will be that way for a period of time. They may also complain of either pain in those areas or just numbness, tingling, and those kinds of things. That's probably due to a parasympathetic nervous system injury.
At the hospital, I thought I had a stroke because half of my face was drooping down, but I ended up with a 20% hearing loss in my ear. Lost part of my eyebrow where I got hit there. It doesn't grow back, so I have to trim the other one to make them look even. But aside from that, I went through a year and a half of hell.
Its unpredictability and power make lightning protection an extreme challenge. Where will it strike? What protective measures can we take? To help answer these questions, at Camp Blanding near Gainesville, Florida, scientists spend the summer months triggering lightning strikes, using principles that Benjamin Franklin would easily have recognized. Here they fire rockets up into the heart of active thunderclouds. The site lies in Lightning Alley, a belt of land across central Florida. Lightning Alley has more thunderstorms than anywhere else in America. The rocket trails a fine copper wire behind it. The idea is for lightning to strike the rocket and then follow the wire down to the ground. The researchers can then study and measure the effects of lightning at close range.
Fields are starting to go negative. Let's make sure that the Nicolay's are armed. Range control, this is the lightning side, over.
Range control.
Confirm at 1509, going hot. Everything's armed, turning on power, turning on air. Arming for rocket number 1. Fields are at -5. Moving to -7. -7 and arming. At -8 we fire. 3, 2, 1, fire.
This is potentially highly dangerous work. Safety is paramount. The scientists work inside shielded metal buildings, and the rockets are fired using fiber optic cables. If there were any direct electrical link to the launch tower, lightning could travel down the cables and into their safe area.
These are the two styles of rockets that we use at present. These are the spools that we attach to the bottom. It's very strong, and it simply has a copper center to it for the conductivity of the lightning. These came from France. These are the ones we use and are most reliable right now. The biggest problem is we have to use black powder. The motor has 900 grams of black powder under pressure. So they're very dangerous and could ignite at the slightest provocation. Our other style that we're using right now, which is a lot more desirable, and it makes it that way because it's got a parachute attached. Thus it's recyclable. These are a before shot. This is an after.
The main aim of the research is to test cables and machinery used in the electrical power industry. Power cuts are often caused by lightning strikes to large outdoor installations. The researchers measure the enormous power surges during the triggered strikes to help develop new, more lightning-proof systems. Successful triggering requires experience and skill. The moment to launch must be precisely timed. As the negative charge increases in the cloud, sensors measure the corresponding positive field in the ground. They can only fire when this field reaches a critical level.
And fire.
Even then, they're not always successful. They trigger lightning on about 70% of launches. Sometimes they get more than they bargained for, and the triggered lightning sets off much more powerful natural strikes. We cannot predict lightning, but it is possible to detect strikes even hundreds of miles away. Screens at the National Lightning Detection Network in Tucson, Arizona, show every bolt in America within moments of it happening. Every lightning bolt emits a pulse of radio. A network of antennas picks up each pulse and calculates the strike's exact position. Each year in America, there are over 20 million bolts. The system detects them all. Gunner Blank uses a similar but portable radio detector to help him hunt for lightning storms.
Oh, nice one. The storm's putting out pretty good lightning over here.
Gunner is a cameraman. He shot most of the lightning in this film.
We got some 3 to 8 miles away.
His detector cannot pinpoint each bolt's position, but it can tell him how far away it is.
Another one 8 to 20.
Most probably it's going to be where the rain has fallen, or just outside it. And we're up here on a little bit of a hill, so we're kind of exposed.
Gunner's problem is to know precisely how exposed he is. How big a risk is he actually taking?
With a lightning detector, it just gives us an idea of how far away the bolts are. You can also look and see. 0 to 3. This is going to be an inside the car storm pretty darn quick. Another one.
As the storm approaches, the lightning strikes get nearer and more frequent. These are perfect filming conditions.
Ooh, beauty! Oh, beauty. Oh, that was a nice one. That's close. That's close. I'd like to get a lightning bolt coming right down the side. Just got it! Whoa, that was close. Oh, that was close. That was right down here at the end of the road. All right, these things are getting a little bit too close. So, okay, let's get in.
A car is the safest place to be in a thunderstorm. For Gunner Blank, who spends so much time near lightning, it's his only shelter. Most people assume cars are safe because they have rubber tires, but that's not the reason. In this high-voltage laboratory in the UK, an experiment is carried out to show exactly why a car is such a good shelter. Theoretically, if the vehicle is struck by a high-voltage spark, its metal chassis will conduct the electric current around the person inside the car and down to earth through the tires. It would be perfectly safe to sit inside the car during this experiment. However, safety regulations insist that a dummy is used.
8, 7, 6, 5, 4, 3, 2, 1.
The dummy has been wired up so any current passing through it can be measured. Time and again, a 2 million volt spark strikes the car, and each time the dummy is untouched. In these laboratory conditions, at least, the theory works. You really are safer inside a vehicle during a thunderstorm.
The man on shore who had come down to help, he said I'd long passed the blue stage, and there were people standing around telling him to give up on her. She's gone. Leave her alone. She's dead. And he refused to stop. He said, I'm not stopping. And he kept working on me until the paramedics got there and took over. And then it took them the 4 minutes before they got those vitals. The short-term memory for the first year after the accident was very much a problem. I could ask my husband a question 6 times, same question, probably within 10 minutes, and not remembered that I had asked. We even went home for Christmas the same year that I was hit, and I don't remember being in California for Christmas.
The major things that I experienced was equilibrium problems. I would just fall over without any warning. Mood swings. I'm a man who's always had a sense of humor, and I lost my sense of humor.
An analogy would be if you ran an electric shock through a computer. The outside of the computer looks okay. Probably if you took the casing off, the inside of the computer would look okay, but the software wouldn't work. Same thing happens with a person. Is very often they'll have memory deficits, problems with short-term memory, in particular with coding information, so that they can carry on a perfectly decent conversation with you in the emergency department, and then if you see them the next day, they don't remember they've ever spoken to you. Could be.
Hitting the
Welcome to the 6th Annual Lightning Strike and Electric Shock Victims International Organizational Meeting, Gettysburg, Pennsylvania.
The physical and emotional problems lightning victims encounter are hard for anyone else to comprehend. So every year, survivors meet to share their experiences with each other. The only people they know will understand.
The next thing I know, my husband rolled me over and says, "You're going to be all right." And I thought, oh, I can't talk, I can't move. What's he talking about? And then I heard somebody say, she's been struck by lightning, and I heard all kind of people running around.
And what I noticed is for a split second, I'd seen a glow around my hand, and a really odd feeling. But before I could even think about it anymore, it snapped. She's seen a big bolt come over some treetops, and why it hit the van, I don't know. There's quite a few.
The group was set up by Steve Marshburn, himself a lightning victim.
From the time I was injured, I'd been corresponding with other people that had been struck by lightning, and I knew something had to be done because I knew others must be hurting as badly as I was for information, for answers. I've learned to deal with the capabilities which I have right now. I treasure life every day.
We are all increasingly vulnerable to lightning. Strikes can damage the technology our society depends on as easily as it can hurt people. Yet, even today, the best way to protect our fragile, high-tech communities is with a device 200 years old, the lightning rod. The rod must be strong enough to withstand the huge voltage and current of a strike. And in this outdoor experiment in Japan, lightning conductors are being tested with simulated lightning. 3 million volts of electricity jumping at least 20 feet to the ground. With a lightning conductor, the electricity is directed harmlessly away from exposed brickwork down this electrically conducting tape. At the bottom right of the picture, you can see where the simulated lightning is arced to the ground, safely away from the block. Without a conductor, the effect can be devastating. The more sophisticated our technology becomes, the more vulnerable it is to lightning strikes. And one of the most vulnerable technologies of all is the airplane. In the air, a plane's radio systems, radar, and fuel tanks are all potentially at risk. In the 1980s, NASA flew this jet fighter right through the heart of active thunderstorms. Their aim was to learn more about plane safety by getting lightning to strike the plane. They succeeded. Today, every airplane's metal shell is carefully designed to conduct any lightning bolt around the outside of the craft in complete safety. But with a machine as sophisticated as the space shuttle, these simple measures are not enough.
We are go for golden start. 5, 4, 3, 2, 1. Booster ignition and liftoff of Atlantis on a mission to study planet Earth.
The space shuttle is a multi-billion-dollar combination of high explosive fuel and delicate circuitry. A direct lightning hit could easily destroy any of the millions of electronic circuits on board the craft. The shuttle's lightning protection system is possibly the most complex and advanced in the world. It has to be. The Florida launch site is right in the middle of Lightning Alley, and the launch tower is the highest object for miles. It's vital to detect any lightning storms that may endanger the shuttle and to protect the spacecraft if it's hit. NASA's first line of defense is accurate prediction of when and where thunderstorms will occur. At Cape Canaveral Air Force Base, A special weather group monitors the buildup of storm systems 24 hours a day. If lightning comes to within even a few miles of the shuttle, stringent safety measures are immediately put into effect. If it's during the countdown, the launch will be halted if there's the slightest risk of a lightning strike.
Lightning is expected to occur within 5 nautical miles, starting at 13:45 local time to 15:45 local time. A warning will be issued when lightning is imminent or occurring.
The forecasters here get their information from satellite data, radar, and other sophisticated monitoring systems. A network of specialized antennas is scattered over the launch complex. These show when the electrical charge in the ground rises as the storm clouds pass over, giving warning of impending strikes. But it's inevitable that the shuttle or the launch tower will sometimes be hit by lightning, as this NASA security camera footage shows. So the second line of defense is physical protection. On the very top of the launch tower is an 80-foot fiberglass mast, which supports a lightning rod, attached to a 1-inch stainless steel cable that runs over its top. The cable stretches 1,000 feet in both directions, down to where each end is anchored and grounded. Any close strike should be attracted to the lightning rod, then travel down the cables to the ground. An old-fashioned photographic flashbulb provides a low-tech but effective way of confirming a strike. If the bulb is blown, the cable was hit. The shuttle's main fuel tank contains nearly 500,000 gallons of liquid hydrogen and oxygen. It too is protected by a sturdy lightning conductor. Throughout the shuttle, the delicate electronic circuits are shielded against power surges, just in case a lightning bolt gets past the protection systems. So far, it hasn't happened, and with the safeguards that NASA operates, it never should. Once in space, the view from the shuttle reveals the true size and power of lightning. By day, enormous tropical thunderstorms roll over the islands of Indonesia. At night, the skies over America come alive with huge displays of lightning. On our planet, there are 6,000 lightning bolts every minute, each producing its own pulse of radio. At one particular frequency, those pulses can be heard around the world. Pick up that signal, and you can listen to the sound of all the lightning everywhere. And as these lightning storms travel through our planet's atmosphere, they subtly change it. We now know that lightning plays a major role in sustaining all life on Earth. This plane is part of a complex scientific research program in Colorado, designed to analyze lightning's effect on the atmosphere. The plane has been fitted out with devices which suck air into instruments fitted inside. It flies at low level around and sometimes directly underneath active thunderstorms. The researchers can then analyze how the lightning alters and affects the chemistry of the air. Lightning literally burns the air it passes through, generating new chemicals from the atmospheric gases. These include nitrates, essential for all plant growth, which dissolve in the rain and fall to the ground. Lightning may have created more than half of all the Earth's nitrates. And every lightning bolt creates ozone. The thunderstorm's convection drives some of this up into the stratosphere, where it adds to the Earth's ozone layer, protecting us from the sun's deadly ultraviolet rays. With each flight, these scientists are discovering more ways in which lightning contributes to the complex balance of nature. With every new discovery, lightning offers us new surprises and new mysteries. For years, pilots flying at night have reported seeing huge but very weak flashes of light that shot upwards into the sky from the top of thunderstorms, so quick and so faint that they were barely visible. Scientists had no physical explanation for these lights, and so they tended to dismiss the stories. These first images rocked the scientific community. They called the flashes sprites, strange, elusive, and scientifically inexplicable.
Yeah.
Now there are projects around the world trying to establish the precise nature of these mysterious electrical discharges.
Right in the middle of Sprite Alley.
This research station on the top of a mountain in Wyoming is one of them, using specialized low-light level video equipment to capture them on tape.
Better, these clouds are clearing out. Yeah, I think these clouds will all clear up.
Sprites are immense. They shoot up from the top of a 12-mile thundercloud to heights of 60 miles or more. This means the researchers must observe them from a great distance. From this mountaintop, they watch thunderstorms on the Great Plains, up to 500 miles away.
Hope for the best. We can always change it if
This is the one right on the corner between Wyoming and South Dakota and Nebraska. And we can see that lightning when we go out.
The secret to success is choosing in advance which will be the best storms to watch, and then aiming the cameras in exactly the right direction.
off a positive and
Then they must wait for nightfall. Sprites can only be seen at night using ultra-sensitive cameras. The human eye can just about see them sometimes, but too faintly and briefly for useful observation. Rare color footage taken from a high-flying plane shows that sprites are red in color, and these vast shapes may occupy as much as 2,500 cubic miles in volume. What causes sprites is a mystery. They always occur immediately after and directly above a conventional lightning flash. But not every lightning flash creates a sprite.
All right, we're ready for the sprites.
All right, let the show begin.
The latest theory is that they're produced during rare positive lightning strikes, bolts that rip down to the ground from the very top of the cloud. The researchers have also discovered a second phenomenon. These upward sprays are called jets. They're fainter and quicker than their cousins, the sprites. The precise cause of sprites and jets, what they're made of, and above all, what effect they might have on the upper atmosphere, are all still unknown. For all our growing understanding, lightning still has its mysteries.
I still get jittery when it's lightning out. I try not to fear it, I try and respect it, but if it's lightning real close by and pretty severe, I go for cover.
And I survived it. People do survive it. You take what's dealt to you and you move on.
Lightning storms have lit our skies since the world began, bringing us fear, but also an irresistible fascination.
I probably shouldn't say this on tape. I love lightning. I think it's one of the most fantastic natural, phenomenal types of things. It's one of the greatest gifts that we've been given. It's just beautiful. Although I can understand to the victims how frightening it can also be. Do I take all of the precautions that I tell other people to do? No. I sit out on my front porch and I watch it because, and I've told my family that when we retire, we're going to have to find a place where we can watch lightning and watch the thunderstorms coming.
3 to 8. Well, we're going to hang on. I still think we're going to get some more out of this.
Lightning. Beautiful, intense, lethal. Yet despite its terrible danger and immense destructive force, there will always be those who are willing to defy the awesome power of our raging planet.
God.
Someplace right in this area is when I was struck by lightning. It was never overhead, it was back beyond the trees, and I believe I've been told it's what they call arc lightning, where it travels ahead of the thundercloud about 10 miles or so and travels horizontally and then makes its contact, and I and the jet ski were its targets. Apparently it forked and entered my left shoulder, and a piece of it went through the jet ski.
Lightning singles out its victims with random, almost casual savagery. Small wonder so many cultures have seen it as a tool of the gods. For the ancient Greeks, lightning strikes were Zeus's thunderbolts, sent down as punishment. In New Mexico, the Pueblo Indians believed in the thunderbird, a mythical eagle whose eyes flashed lightning and whose wing beats were thunder. In northern Australia, the Aboriginal people have lived with lightning for thousands of years. From November to January each year, this land experiences some of the most powerful and dazzling thunderstorms in the world. For the Aborigines, this was the work of the Lightning Brothers. They painted them on rocks throughout the region. These were warriors, tribal brothers who fought over a woman. As their stone axes clashed, the sparks became lightning. The noise of the fight was thunder. In one story, the triumphant brother had children, rows of baby lightning flashes, waiting to be released. Yet even in this scientific era, lightning continues to fascinate us. And even simple questions have proved hard to answer. How do thunderclouds become electrified? What causes lightning? Thunderstorms are water and heat. When pockets of moist air are heated by the sun, they rise. As they gain height, the air around them becomes cooler and the atmospheric pressure lower. The moisture cools and condenses to form clouds. This process lies at the heart of all cloud formation. But to create lightning, it must go further. When conditions are right, with enough water and heat to drive the system on, the first small clouds grow and merge into larger ones, rising all the time. Some of the water drops become too large and heavy for the updraft of air to support them, and they fall as rain. But strong convection currents lift the smaller droplets higher and higher, and in the cold upper region of a stream of raw power, hotter than the surface of the sun. At any one moment, there are at least 2,000 thunderstorms raging across our planet. Lightning is all around us, a natural force of almost unbelievable power. Yet lightning is still a mystery to us, despite 200 years of research. We still have no answers to the most fundamental questions. What causes lightning? Where will it strike? And when?
I've been told that a single bolt of lightning is up to 20 million volts and about 50,000 degrees Fahrenheit. That's a lot of power. It's an awful lot of power, and I survived it.
Lightning kills over 100 people in America every year and injures 500 more. Around the world, the death toll runs into thousands. And its victims are not always beneath a thunderstorm. Lightning can strike literally out of the blue. This was the experience of Michelle Dougherty. She was struck while jet skiing on a clear summer day.
It was beautiful. It was hot and it was sunny, and we were rented 2 jet skis for an hour, and it was almost at the end of the hour that the accident occurred. We were out playing around on the jet skis and then heard after several moments a very faint, distant rumble. And we were heading back into the docks and...
Lightning, hotter than the sun. Tens of miles long, yet only an inch thick. The most powerful electric force on Earth. Created by ice, yet it burns. It kills. It injures.
I went through a year and a half of hell.
Fire. We can capture it, imitate it, but we can never control it.
Just got it. Oh, right down the side of that rain shaft.
Lightning, the violent power of our raging planet. The beauty of the clouds, majestic, tranquil, deceptive. For inside this storm cloud, vast forces are at work. Simple ingredients, moisture, heat, ice, combine to create one of the most powerful phenomena on Earth. Lightning. There are 10 million lightning bolts around the world each day, more than 100 every second. Each bolt is less than an inch thick and reaches miles across the sky. Cloud, they freeze into tiny crystals of ice. At the top of the cloud, as much as 12 miles high, they spread horizontally, forming the flat anvil shape of a typical thundercloud. More water freezes onto the ice particles, and they grow into hailstones, which drop back through the cloud. They fall through the stream of smaller rising particles, causing millions of tiny collisions. Each collision knocks electrons off the rising ice crystals, giving them a positive electrical charge, while the falling hailstones become negatively charged. Eventually, the entire cloud becomes electrified, like a giant battery, positive at the top and negative in the lower regions. Something has to give. A huge electrical current rips through the air to neutralize the two charges. A bolt of lightning has been created.